Good morning all. Okay, so let's start. The students are joining. Okay, let's start. Now see the screen. One question is given. Now tell me what is the output of this question. So the output is 20, right? So this type of calling the function and passing the arguments, it is of type what? Call by value or call by address or call by reference method?
Call by name.
This is call by value method. Call by value method. Okay. So in C++ already you know, if you already C++ in the second semester you have some additional course. So at that time already you know in the call by reference, one is call by reference. So this one is call by value method. Another one is call by address method. Okay. So that means now y equal to 20. This is assigned the value of y equal to 20, and you are passing in that function. You are passing the value of y. Okay. You are passing the value of y. So this is actual parameter and this one is the formal parameter. Y is the actual parameter, x is the formal parameter. So the value is copied. The value is copied. Okay. That means the value of x equal to 20. So inside the function, the value of x is changed to 30. But it is not reflected in the main function. Okay. Because in this type of method, you are going to create two different variables. So you are going to create two different variables. One is y, the value of y equal to 20. So now this value of y is copied to the value of x, the value of x equal to 30. Okay, so these two, please mute. Please mute.
This is on top of my head.
Okay. So in this case, you are going to create two different variables in different memory location. For example, y is stored in memory location 100, x is stored in memory location 200. So now the value of x is changed, not the value of y is changed. Okay. So because both the variables are stored in different memory location, so any updation in this 200 location will not reflected in the 100 memory location. That's why after coming back to the main function, if you have to print the value of y, you get the previous value, original value, not the updated value. Because this is the limitation of the call by value method. Any updation in the function definition, it is not reflected in the main function where it is called. Okay. So that's why you have to just modify the program. So let's see the different program. What is the output of this left one? What is the output of this left side program?
30.
Left side program. So this is the way you are going to call the function, pass the parameter. It is called as the call by address method. So this one is value method. This is called by address method. Very good. This is called by address method. That means now you are passing the address of y. The address of y equal to that 100. Now the 100 is passed. Okay. That means now this is asterisk ptr, means it is a pointer. Already I said what is pointer. Pointer is going to hold the address of any other variable, of any other function object like this. So now this pointer is going to hold the address of y, which is nothing but 100. Okay. So this is the declaration of the pointer. Right. Now I am going to write asterisk of ptr. That means value at that location. That asterisk, this asterisk is used for the value, to find the value at the location. So the value at the location is now changed from 20 to 30. In that location 100, previously it was 20, now it is changed to 30. Okay, that means when I am coming back to the main program and I have to print the value of y, so I get the reflected result. I get the reflected result, that is 30. So in this program I get the value 30, but in this program I get the value 20. Okay, so this limitation of call by value method is overcome by the call by address method, because you are directly handling at that address. Okay, in the call by value method, the limitation is you have to create duplicate variables. Just it is the wastage of memory space. Okay, so another one is the call by reference method. For that you have to use the reference variable. Okay, so like this part. So now already I said in the linked list. Linked list, it is nothing but the collection of nodes. See this one in my previous classes already I said. So linked list, it is the collection of nodes. It is a series of connected nodes, and each node contains basically two parts. One part is the information part, other part is the address to the next node. If address it is not pointing to any other node, so the address equal to null. Okay, then what is that? It is a pointer. Pointer means it holds some address. It holds the address to the first node, and the last node, if the value equal to null, that means the address equal to null means there is no node after this node. It is the last node of the linked list. So this part already it is over. Now what are the different operations on the linked list? For any linked list, you have to create a linked list, you have to display the linked list, insert, delete, merge, sort. These are the different operations on the linked list. That linked list may be single, double, or circular linked list. So next question is how to create a single linked list. Okay, again because I am discussing this topic again so that you have no doubt in any way of doubt to how to create a linked list or how to handle any kind of linked list. Okay, so to create a linked list, I need a self-referential structure. So this is the example of self-referential structure. So for that, I create a structure. One part is the information part, other part is the address part. That means if I have to create a variable for this structure type, again if I have to create a variable for this structure type, at that time some memory is allocated, and I have that memory is nothing but the some node is created. Then my task is I have to give the address part and I have to give the information part for that node. Okay, so now see here, when you have to create this kind of node, right? So for that, when you have to create a single linked list, first step is allocate memory. Allocate memory for the node, for the new node. Okay. So when you have to create a node, first step is you have to allocate memory for the new node. For this allocation of memory, you have to use the malloc function. Malloc function. Malloc function, it is nothing but the dynamic memory allocation. You are going to allocate memory dynamically. So it is the runtime allocation of the memory that malloc function is used. Okay. So who can say what is the syntax of this malloc function to create a node? What is the syntax?
Size of struct node, as we take the size of struct node here.
Okay.
And
so before that, just one step you can do.
Typecasting.
Typecasting.
We need to do
struct
typecasting.
Typecasting. Okay, typecasting, that is type def, not typecasting. It is type definition. You have to redefine the data type. Okay, type def. You have to write type def struct node. Type def struct node. So you can give your own name also. It does not matter. The program will program will run smoothly. Okay, you can give any name. So type def struct node. I give the name of the structure is node. Okay, I give the name of the structure is node. Then a semicolon. This is the C syntax. You have to redefine. You have to give an alternative name for the existing data type. So node is the new data type. Now create node asterisk ptr. Suppose ptr is the name of the node. Ptr is the name of the newly created node. Okay, so node asterisk ptr. So next thing is you have to allocate memory by the malloc function. Allocate memory by the malloc function. So for that, I have to write ptr equal to node star malloc size of node. Size of node. So any doubt in this statement? Batao. ptr equal to node star malloc size of node. Be clear in the syntax. Every time you have to, when you have to write any creation of any kind of node, maybe the single linked list node, double linked list, or sublet linked list. For memory allocation, you have to follow the syntax. PTR. PTR is a pointer of which type? Node type. PTR is a pointer of node type. Okay. So you have to do the typecasting. This is called as the typecasting, because by the malloc function, some room is allocated, some memory is allocated, and you have to occupy a node of the this type of node. This type of node. So you have to do the typecasting. That is node star. Then malloc is the function. Size of operator is used to calculate what is the size of that particular node, and that much amount of memory is allocated by the malloc function. Okay. When this program is executed by the compiler, then what happens? If you have in the computer's memory some sufficient memory is there, then malloc function is going to allocate memory. So in this case, 8 bytes of memory, one for the integer part, other one for the address part. 8 bytes are allocated, and the starting address, let the starting address, let I'm saying let the starting address equal to 100. It may be anything. Okay. In my previous class, I have executed program. You are getting the address like 21167, like 6 or 7 digits. Okay. Let the address equal to 100. This 100 is returned by this malloc function. As a function is going to return some value. Now this malloc function is going to return the address. Okay, what is the address? In this case, address equal to 100. This address 100 is assigned to the PTR variable, pointer variable PTR. Okay, so now this is a pointer. Its content is some address. Now the address of this pointer that is held by the pointer is 100. Okay, all of you clear? All of you clear in this sentence?
Yes,
Yes,
ma'am.
ma'am.
So
Yes,
the
ma'am.
question is, okay, very good. The question is, when you have to create a linked list, you have to allocate the memory for the node. How to create the how to allocate the memory? First, you have to write a self-referential structure. So this is self-referential structure. Then this statement is basically used to redefine. Redefine, just give a alternative name for the struct node type. Now my data type is struct node. Just instead of writing struct node every time, I write now node. Okay, this is type there. Now next step is pointer is a PTR is a pointer of node type. Node type, that means now the new data type is node. Okay, in this data type you have two parts. One part is the information part, other part is the next part. That means when you have to create any memory location for the node type, it is having two parts, information or next part. So PTR is a pointer of node type. Then malloc function is used. Malloc function is used to allocate memory dynamically for any node in the node type. Okay, the syntax is, you have to first write the pointer variable name is equal to, then the data type star, that means this is called as the typecasting. Then malloc function, in the function the parameter is, you have to pass what is the size of the memory you have to allocate by the DMA. Okay, so this is all about if your memory space is free, if you have some sufficient memory space, then pointer is going to hold the initial address. The initial, because 8 bytes are allocated, 8 bytes are allocated, and you are getting the address of the first byte. You are getting the address of the first byte. So PTR the value equal to 100. Okay, all of you clear? If you have not sufficient memory, if you have not sufficient memory, that means in the RAM you have not sufficient memory, then how can you display, how can you write that program, how to code this one, how to code? If your memory is not sufficient to create that node, how can I write? If I write if not PTR, then what is the meaning of this one? If not PTR, you can say PTR means some address. If not PTR means it is null. Yes or no? If not PTR, or you can say write if PTR equal to null. Both are right. Okay. If not PTR, basically this type of question you are getting in the gate, they are writing this type of syntax. If not PTR, PTR having some address that is true, not PTR means it is false. Okay. If not ptr, or you can say if ptr is equal to null, then you have to write printf not sufficient memory. Not sufficient memory. Not sufficient memory. Okay. So all of you clear how to create a single linked list? How not, this list is not created till now. Node is created. Okay. So for the creation of the node, first you have to allocate memory. If you have your sufficient memory, that is sufficient memory, the node is created. Else, if there is no sufficient memory, you have to write this condition or this condition. If not ptr or ptr equal to null, you have to display the message not sufficient memory or out of memory, or any message that is going to display that my node can't be created. Okay, my memory is insufficient to create a newly created node. Okay, so now this is the way you can allocate memory. Memory is allocated. Memory is allocated. Okay, so memory is allocated means just a template. Okay, memory is allocated. Let address equal to 100. Initial address total equal to 8 byte. So this is the address of the first byte. Okay, 4 byte for the information part, 4 byte for the address part. 4 byte and 4 byte. 100 let. So this is let. I'm saying again. Let the address equal to 100. This is the address of the first byte. Okay. So now you have to give the information part and the address part. Next one is what is the information part, what is the address part. Okay, so you can say this is my information part, this is address part, or link part or next part. Okay, so ptr, this is the pointer. So this is the pointer that is going to point to the first byte of the newly created node. Next question is, how can I give the information part of this new node? How to write the C program? How can I write the C program so that I can give or input the value to the information part? Batao?
ptr.info.
ptr.info or ptr arrow info?
Arrow.
If
Arrow
there's
info.
pointer pointing to a structure, then arrow operator.
Now I'm discussing it is a pointer. Okay, because it is the dynamic memory allocation. So ptr is the pointer. So by the arrow operator, you have to give the input to the information part. ptr arrow info. If you have to give the input directly, you can write ptr arrow info equal to 25, or by the scanf function, you can also write address of ptr info. Okay, both ways. Suppose it is the direct initialization. In that information part, what is the value? The value equal to 25, or by the keyboard, you can give the input by the scanf function. By the scanf function, you can write address of ptr arrow info. Okay. Then information part, I'm giving it is suppose 25. 25 is entered by the keyboard or by the direct initialization statement. Okay. Now what is the address part? What is the address part? You have to just go to the linking part. Okay, it is going to address to the what is the next node of the linked list. If it is null, if I write, see here, if I write ptr next equal to null, then what happen? ptr next equal to null, then what happen?
Then the address part is replaced by null.
Next node points to null.
It is equal to null. Okay, that
Yes.
means now only one node is created, only one node is created, and this is only the single node, and there is no next part, there is no it is not pointing to any other node of the linked list. Okay, so for this single node, what you have to do, another statement, that is start equal to ptr. Start equal to ptr. Okay, that means what is the meaning of this statement? Start equal to ptr. Just you have to maintain which one is the first node of the linked list. Okay, start is a pointer of node type. Okay, start is a pointer. Initially you have to write start equal to null. Initial start equal to null. That means there is no node in the linked list. If I write start equal to ptr, that means start pointer is now pointing to the first node of the linked list. Okay, all of you clear? So till now what we have done, first statement is for the creation of the single linked list, creating or inserting. You have to create a new node. To create a new node, by the dynamic memory allocation, by the malloc function, you have to create a new node. Okay. If your memory is sufficient, node is created. If memory is insufficient, that is if ptr equal to null, that is memory is insufficient, the node is not created. Okay, you can assume that node is created. Okay, then next step is you have to give the information part and you have to put the what is the address of the next part. So the information part can be given by the ptr arrow info or address of ptr arrow info. Okay, this is the information part. Then what is the address of the next part? If it is null, it is the last node. Otherwise, you have to create a new node and you have to assign the address of the new node to the next part. This is called as the insertion at the end of the linked list. Okay, let's see. So this step already I have discussed. You can see here. Now see. So step 1 is how to now creation is over. Now the insertion operation. How to insert a node? You can insert a node at the beginning of the linked list. Let us first discuss. So for the insertion operation, now the node is created. First node is created. Okay, first node is created. Start is pointing to the first node. Address part equal to null. Okay. So next step is you have to insert a new node. You can do the insertion at the beginning. You can do the insertion at the end. You can do the insertion at any position. Anything at any position, after any value, before any value, like this. So these are the different insert operation. Okay. So for insert operation, first step is create the new node, allocate memory or create a new node. Create or allocate memory for the new node. Okay, so first step for the insertion, for any kind of insertion operation, first you have to allocate memory for the new node. Okay, so now let's see. I'm going to discuss. You have to insert at the beginning. How can you write the algorithm so that the node is inserted at the beginning position? Insert at the beginning. Okay, so for the insert at the beginning, first step is you have to allocate memory for new node. For new node, let the new node name is ptr. Okay, so for that you have to declare pointer of node type, declare ptr of node type,
नोटिफिकेशन के साथ ही डालना पड़ता है।
declare ptr of node type. Okay, so how can you declare the pointer of node type? Simple statement. Write node star ptr. If I write node asterisk ptr, so you are going to declare a pointer. Its name is ptr. Its type equal to node. Okay. So for the memory allocation, you have to write ptr equal to node star malloc size of node. ptr equal to node star malloc size of node. Okay. If third statement is if ptr equal to null, then what happen? If ptr equal to null, when I get the situation, when this condition is
Not
true,
sufficient memory.
you have to display that message printf out of memory or not sufficient memory. Not sufficient memory. Very simple algorithm to create a node at the beginning or insert a node at the beginning. Okay, if ptr equal to null, not sufficient memory. Printf, write the proper syntax. Okay, else means some memory is allocated. You have to give the information part and the address part. Else some memory is allocated and you have to give the address part and the information part. Okay, so this is the algorithm to insert a node at the beginning. Okay, so that means step 4. In the step 4 you have to write ptr info equal to item. Okay, ptr info equal to item by the scanf statement or by the directly you can pass the value from the function ptr info equal to item, right? Then what is step 5? In the step 5 you have to write if this node, that node that you are going to create, it is the fast node. It is the fast node. How can I check this node is the fast node? What is the statement? How can I check it is the fast node?
If start
If,
equal to null.
very good. If start equal to null. If start equal to null, because start is a pointer that is pointing to the fast node. Okay. If start equal to null, okay, then you have to set what? Set start equal to ptr. Set start equal to ptr. Okay, that means you see here else set start equal to ptr. That means node is created. Up to this, what happened? If you compile the program, up to this, some memory is created. Okay, so the name of the memory of the fast byte, the address of the fast byte is assigned to the pointer ptr. Okay, let it is 100. So now by this statement you are going to give the information part. Let the information part equal to 25. Okay, if start equal to null, it indicates that my start is not pointing to anything. Start equal to null means previously it is null, nothing, no address is assigned to the start pointer. Now start equal to ptr. So what is the value of start now? What is the value of start now by this statement?
Null.
null कैसे होगा? Start equal to ptr. ptr में क्या है
मैम वो
तुम्हारा?
नेक्स्ट एड्रेस पे आएगा।
ptr में क्या
Start
है?
100 रहे
ptr में 100 है.
Point
So
करेगा।
now now the start equal to 100. That means ptr equal to 100. So this one is assigned to the start pointer. Okay, start में तुम्हारा value कितना रहेगा? 100. Okay, that means now start is pointing to the new node. Start is pointing to the new node. Okay, all of you clear? Step by step. ptr info
Yes,
equal to
ma'am.
item means you are going to give the information part. Next statement, step 5. If start equal to null. Start equal to null means now initially previously start is not pointing. Initially it is equal to null. This link was not established. Okay. So start equal to null. If I write this statement, you see if I write this statement, start equal to ptr, 100 is assigned to the start pointer. As 100 is assigned to the start pointer, now start pointer is pointing to the address 100. Okay. So next step is you have to write if this is the fast node, then what is the address part of the ptr? What is the address part of the ptr? Now the address part of the ptr equal to null because it is the fast node. So now ptr next equal to null. ptr next equal to null. Okay, ptr next equal to null. That means now only one node is created. One node is created, its value equal to 25, its address equal to null, start equal to ptr. Start is pointing to the first node, also ptr is pointing to the, because ptr is the name of the node. Okay, else who can say if you have to insert a new node, already some node is created, some node is created.
Have to take another variable, a pointer.
Else that means now some node is present. Okay, some node is present. ptr is not pointing to here. ptr is pointing to here. ptr is pointing to here. Okay, let the address equal to 200. Okay, ptr is pointing to this newly created node. So this is the already existing list, and you have to insert this ptr in the list. That means you have to insert this node at the beginning. Beginning means now you have to insert the, you have to establish the link like this. You have to do the linking in this way, and start will point to this node. Okay, then it is called as the insertion at the beginning. So in the
And we
else
have to
part,
increment the point.
increment just the assignment. Assignment means if I write, you see, if I write 100 here, if I write 100 here, what is 100? 100 is present in the start variable. Yes or no?
Yes.
Start pointer. Okay. If I assign 100 here, if I assign 100 here, then this link is established, right? Okay.
Yes.
And if I write start instead of 100, if I put 200 here, then start is pointing to here. Start is pointing to here. That means now ptr is the first node. This node is the second node. Okay. So I'm writing the code. Else means ptr next. ptr next equal to stat. देखो ये वाला स्टेटमेंट ठीक से समझो. ptr next equal to stat. Stat में क्या है? If the node is first time created in the stat is equal to 100. Okay, what is the value? Stat equal to 100. So ptr next equal to 100 means now you are going to put in the next part of ptr the value equal to 100. Okay, 100 is now assigned. Now you have to write stat equal to ptr. Stat equal to ptr. That means what is the value of ptr? The value of ptr equal to 200. So 200 it is assigned to the pointer stat. It is assigned to the pointer stat. So this assignment is over. That means now ultimately you are going to create this node. This node ptr is inserted at the beginning of the linked list. ptr is inserted at the beginning of the linked list.
Ma'am, all things got messed up. Can you please explain once again?
Okay. I'm erasing completely. Okay. What is the algorithm? Insert at the beginning. Insert at beginning. The algorithm is insert at the beginning position. Okay. What is step 1? Step 1 is first you have to declare a pointer. What is pointer? Pointer is pointing to the newly created node. All of you clear? What is pointer? Pointer is a pointer. Suppose this is the newly created node, because you have to create a node and insert at the beginning position. Okay, before that first you have to create the node. Yes or no? When you have to create a node, what is the address of the first byte? That address of the first byte is assigned to the pointer variable ptr. Okay, suppose this is the new. Suppose new student is getting joined to the college. For that new student, some registration number or roll number is assigned. Okay, so what is the this new student? Then what is the structure? This is a student type. Similarly, what is this pointer? Pointer is a node type. Okay, this is a pointer is a variable of which type? Node type. Clear? So first you have to declare pointer of kind node. It is a node type. That means what is the statement? In C you have to write node star ptr. This is the declaration of the variable, like integer a, integer b, integer c. You are going to declare pointer. Pointer of which type? Node type. All of you clear this statement? Node asterisk ptr means ptr is a pointer of which type? Node type. It indicates that in the ptr some address is assigned. Okay, some address is assigned. In that address location, which kind of node is present? So this is a node is present. In that node you have two parts. One part is the information part, other part is the address part. So this is the meaning. Okay, so ptr is going to hold some address. In that address, not integer value is present, not float value is present. It has a structure of a node is present. In that structure contains two parts. One is the information part, other is the address part. Okay, so this is the declaration of the ptr. If I write int a, then what happens? A means it can take only integer value. Okay, so now ptr is going to hold some address. In that address you have a kind of student. For that student, a registration number is assigned, a roll number is assigned, and some branch is assigned like this. Okay, so this is declaration of the pointer of type node. Just declaration like int a, int b. You are going to declare a pointer of which type? Node type. Okay, second statement. Then you have to allocate memory. Next statement is you have to allocate memory. So how can I assign the memory? You can allocate the memory by the malloc function. Then what is the statement? ptr equal to node star malloc. Okay, size of node. Be clear in each and every statement so that you can write any program of any kind of linked list. Node star malloc size of node. So this statement is basically for the dynamic memory allocation. Okay, when that student is getting registered in this college, he has to be occupy some seat in the classroom. Okay, that means how to occupy that memory? He has to pay some money in the college fee. Then after the student is registered in the college, or some room is allocated. Here also, now you have to create the memory, create the room for the newly allocated node. Okay, because linked list is the collection of node. Okay, you have to create the memory for the node. So these are called as the nodes. By the malloc function, you have to create the memory for the node. Okay, this is the syntax. If ptr is having some value, if ptr having some value, if ptr equal to 100, let the address equal to 100, then what is the value of ptr? Ptr is pointing to the address that newly created node is present. Okay, if ptr is equal to null, then what happens? If ptr is equal to null, if ptr is equal
Out
to
of
null,
memory.
out of memory,
Out of
out of memory. That means तुम्हारा मेमोरी में कोई जगह नहीं है ये वाला न्यू नोड को ऑक्युपाई करने के लिए. Okay, that means ptr is equal to null. It is insufficient memory, out of memory. Your memory is not sufficient to hold the create the newly allocated memory. Okay, so it is out of memory. Else means already some memory is assigned to the pointer variable or the node is created Okay, that means now the next step is you have to keep the information part, you have to keep the address part. You have to keep the information part, you have to keep the address part. Okay, else you have to set ptr info equal to item. Else you have to set ptr info equal to item. Okay, let my item equal to 25. Let my item equal to 25. So ptr info equal to 25. 25 is assigned to the information part of the new node. ptr is the new node. 25 is assigned to the information part of new node. Okay, and already you can say this is the first node because then okay, how can you know this one is the first node? How can you know this one is the first node?
start is equals to ptr.
So this is second step, this is third step, this is fourth step, this is fifth step. If start equal to null, if start equal to null, that means till now start is not pointing to any node. After creating this node, you have to point start to the newly created node, and this is the first. This will become the first node of the linked list. Okay. So to test whether my list having empty or list having some element, you have to write this condition if start equal to null. If start equal to null, okay, can I erase all the previous statements? Any doubt?
Yes, ma'am.
If start equal to null, that means up to the step number 4, up to the step number 4, one node is created. Listen again, one node is created. The name of the node is ptr and the value of the node equal to 100. Value of ptr equal to 100. Okay, because the address equal to 100. The initial address of the first byte equal to 100. By this statement, information part of this pointer variable is equal to 25. You are going to give, this is the information part of the node. Then what is the address part? Okay, address part till now it is not decided. Okay, whether you have to insert at the beginning or it is the last node of the linked list. I'll write it later. So now if start equal to null, start is a pointer, initially start equal to null. It is not. Null means start is not till now pointing to any node of the linked list. So if this condition is true, this node is the first node of the linked list. Okay, the new node created, this is the first node of the linked list. So for that you have to set start equal to ptr. Start equal to ptr. Again listen, start equal to ptr means what is the value of ptr? The value of ptr equal to 100. So this 100 is assigned to the start variable. That means now the value of start equal to 100. Start is pointing to the, so this node ptr is the first node of the linked list. Okay, ptr is the first node of the linked list. Start equal to ptr and ptr next equal to null. Ptr next equal to null. Ptr next equal to null. That means now, so this is the structure of the linked list. This is the structure of the linked list. Okay, so this is the first node of the linked list. This node is the first node of the linked list. Start is pointing to the first node of the linked list. Okay, else means, okay, if part all of you clear? If part means now for the first time when you are going to create a node, the newly created node will become the first node of the linked list. This is the if part. Else part means already some list is already present and you have to put the new node at the first position. You have to put the new node at the first position. Okay. See here, else So I can redraw the diagram. So this is the start pointer. Start is pointing to this node. The value of start equal to 100. So PTR is not, again PTR is not equal to 100. So create a new node. This is the new node. ये वाला नोड तुम्हारा फर्स्ट पोजीशन में इंसर्ट करना है, ठीक है. सो व्हाट इज द नेम ऑफ द न्यू नोड? द नेम ऑफ द न्यू नोड इज ptr. Let the address of new node equal to 200. Okay, so ptr info, already by the ptr info statement you are going to give the information part equal to 15. Okay, so this is the structure. For this node you have to insert this node in the linked list at the first position. ये वाला पोजीशन में हमें इंसर्ट करना है, ठीक है. So तो क्या करना है? Just do the assignment. Do the assignment means what is the next part? Okay, अगर हम ptr next में ये वाला एड्रेस रखेंगे तो क्या होगा? ये वाला लिंकिंग एस्टेब्लिश होगा, ये वाला लिंक एस्टेब्लिश हो जाएगा. सो ptr next as ptr next इक्वल टू स्टार्ट. ओके, ये वाला नोड का जो तुम्हारा लिस्ट में जो नोड प्रेजेंट है इसका एड्रेस कहाँ पे स्टोर है? स्टार्ट वेरिएबल में. ओके, इफ आई राइट ptr next equal to start, that means now I am assigning the address 100 to the next part of the new node, to the next part of the new node. Okay, so now it is pointing to the already the first node, that was the first node of the list. Okay, now I have to do some assignment so that this new node ptr will become the first node, right? That means just I write the statement start equal to ptr. If I write start equal to ptr, then what happen? Now initially start equal to 100, just I have to do the assignment. Now ये वाला start, this is not the first node, this node will become the first node. 15 will become the first node, 25 will become the second node. So for that I have to do the assignment start equal to ptr. ptr में क्या है तुम्हारा? तो 200 है, so you have to assign 200 to the start pointer. Okay, assign 200 to the start pointer. If I assign 200 to the start pointer, so now this link will be disconnected. This link will be disconnected. Start will point to this one. Start will point to the node 15. Okay, so node 15 will become the first node of the linked list. Node 15 will become the first node of the linked list. Okay, so and 25 will become the second node of the linked list. So what is the assignment? ptr next equal to start. So give the address of the which was the first node, the address of the first node to the address part of the new node, that is 100 is assigned to the ptr next. Now write start equal to ptr, that means start is now pointing to the new node which will become the first node of the linked list. So in this way you can insert a node at the first position of the linked list. All of you clear? Or any doubt? Doubt है? So see this algorithm. See, this is the insert at the end, insert at the beginning. Okay, you see here. What is first step? Allocate memory using the malloc function. All of you clear? Because when you have to insert a node, first you have to create the node or allocate the memory for the newly created node. So by the malloc function, first allocate the memory for the new node. Second step, check for the memory full. For the memory full, what is the condition? If ptr equal to null. If ptr equal to null, write memory full. Okay, else enter the value or element, that is ptr arrow info. So you have to enter the information part. Okay, set ptr next equal to start. ptr next equal to start means it assumes that already some node is present and you have to insert the node at the first position. Already some list is present. Some list is present. This is my start. Let this address equal to x. Okay, and you have to insert the node ptr. ptr next equal to start. That means just you are putting the address in this location so that this link will establish. Start equal to ptr. Start equal to ptr means just this statement. This is not linking to here. Now start is pointing to the first node of the linked list. So this is the algorithm to insert a node at the first position of the linked list. You see here. First step. So here you see already some list is present. 18 is the first node. Let address x1. This is the x1. X1 equal to let 100. Let it is 100. This is 200. Because you know address is nothing but the integer value. This is 300. This is 400. Okay. So what is the value of start? What is x1? What is the value of start? What is the value of start? 100. What is x2? 200. x3?
300.
300. x4? 400.
400.
And this one is null because it is the last node of the linked list. And you have to insert a node at the beginning of the linked list. Okay. So for that, first you have to declare the pointer of node type. Pointer of node type. Okay. You see a node is created. What is the name of the node? Name of the node is pointer. Its address equal to x9. Maybe x9 equal to 500. Let x9 equal to 500. Okay. Let x9 equal to 500. Right. So next statement is enter the element to be inserted. So by the ptr arrow info, you have to enter the element. The element equal to 28. 28 is inserted in the information part of the node. Okay. Then ptr next equal to start. You see here ptr next equal to start. You can see which link is established. Now it is pointing to the x1. What is x1? X1 is present where? In the start variable. In the start pointer, x1 is present. That means x1 is the address of the first node. So ptr next equal to start means now you are going to assign this value. As a result, this link is established. Okay. Then what is the next one? Start equal to ptr. You can see now the start is pointing to the newly created node. So 28 will become the first node. 18 will become the second node of the linked list. All of it clear? Doubt
Yes,
with the
ma'am.
follow. Again, I will explain.
Yes, ma'am.
Is not equal to null.
Right, very good. So now I have to write a for loop for ptr equal to start. Right? So for loop contains three expressions. First expression initialization is ptr equal to start. That means now pointer is pointing to the first node of the linked list. And this loop is continued until ptr is not equal to null. Okay. ptr is not equal to null. If ptr is not equal to null, even loop continue karte rahega. Then you have to do the increment ptr equal to ptr next. ptr equal to ptr next. Okay. So in that for loop, you have to display ptr arrow info. So this is the display of the nodes of the linked list. See here. There is no next class. I think at the 12 o'clock you have O class. So in this program, single linked list creation. So std.lib header file is used for the malloc function. Okay. So step 1, first you have to create the structure of a node, and it is the self-referential structure. One part is the information part, other part is the address part. Okay. And I'm going to maintain a pointer. जिसका नाम है start pointer. Start equal to null. Initially start is pointing to null. That means there is no node. Initially start equal to null. That means it is a pointer only. So it is not assigned to any other memory location. So next. So this statement type def struct node to capital node. That means just I am redefining my data type struct node as the new name. The new name is node. Okay. The next function is create single linked list. First you have to create a single linked list. That means first you have to allocate the memory for the single linked list. For the allocation of the memory, first declare a pointer. Because the name of the new node is pointer, declare a pointer of node type. This is a pointer. That's why the declaration is asterisk ptr. And the data type is node. The data type is node type means it has two fields. One field is the information part, another one is the address part. So next statement, ptr equal to node star malloc size of node. What is the meaning of this statement? Again, just for the revision, tell me. So this statement is going to do what?
Allocate memory.
Allocating memory. Okay, that means in this case of self-referential structure, you have two parts. Only 8 bytes are allocated. Only 8 bytes are allocated, right? Only 8 bytes are allocated. 1, 2, 3, 4. This is information part. 1, 2, 3, 4. This is address part. This is info part. This is address part. Okay, let the initial address equal to 100. So this 100 is now assigned to the pointer variable. 100 equal to ptr equal to 100. Okay, after this statement is executed. Whatever the address of the first byte, is now returned by the malloc function and assigned to the pointer variable ptr. Clear? Next, tell me what is the use of this if statement? What is the use of this if statement? Why this statement is written in the program? If not ptr, that means
Check whether the PTR is null or not.
that means ptr equal to null. It means that ptr equal to null. If ptr equal to null, what is the message you have to display? Insufficient memory. That means my memory RAM is not sufficient to run this program or to create the new node. That node is created. It is insufficient to create the new node. Okay. Next statement. If start equal to null. If start equal to null means? If start equal to null means? This is revision. If start equal to null,
First node to insert.
that is this node will become the first node. This node will become that pointer, that is the node that is created. Okay, before that one statement that is I'm missing. This one, enter the information part. Printf enter the information part, and ptr arrow info, you are going to allocate memory for the, you are going to, this node is created, jiska naam hai ptr. Okay, so what is the information part? Whatever the value that you entered through the keyboard, it is assigned to the information part. Let information part equal to 100. Okay, so next part is if start equal to null. So already you have seen what is the value of start. Initialize start equal to null. Okay, already start is initialized to null. That means if start equal to null means, so this node ptr will become the first node of the linked list. Okay, if start equal to null, it indicates that this is the first node of the linked list. ptr will become the first node. ptr is the first node. Okay, ptr will become the first node. So for that, for to do the assignment, I have to do some assignments. Start equal to ptr. तुम्हारा start में क्या था? null था. Initial start में तुम्हारा null था. Now start equal to ptr means let ptr equal to 100. So start में assign हो गया 100 value. That means start is pointing to the location 100. Okay, start equal to ptr. So the value of start equal to 100. ptr next equal to null. Next statement is ptr next equal to null. Okay, ptr next equal to null means ptr is the first and only one node of the linked list. ptr will become the first node as well as it is the only single node of the linked list. Okay. Next step, else. Else means already some existing linked list, you have to insert the node at the first position. Already some list is present and you have to insert the new node at the first position. So for that you have to do the assignment like ptr next equal to start. That means now the new node should point. This is the new node. Start is pointing to some node. Okay. So now क्या करना है? ptr next equal to start means now this node will become the first node. So this link you have to do the assignment. Okay. Start equal to ptr. Start equal to ptr means now start is not pointing to the first node. Start will now point to the ptr. Okay. So this node will become the first node. Already the start is pointing to that node. This will become the second node. Okay. So in the else part, you have to insert the node to the existing linked list at the first position. So all of you clear? So this is the program that is going to create the linked list as well as inserting the node at the first position. The next is display of the single linked list. For the display of the single linked list, again you have to create, because already some list is present, you have to move the pointer. Move the pointer starting from first position to the end of the linked list. Starting from first position to the end of the linked list. So this is pointer p. So for that, first declare the pointer p of node type if not start. What is the meaning of this one? If not start. If not start. Start equal to null. That means there is no list. If now suppose you have pressed the display first as the first option, till now list is not created, the value of start equal to null, you get the message empty list. You get the message empty list, try again. Okay. Else the single linked list elements are. So you have to take a for loop. Else the single linked list elements are. Let I draw a complete picture. Let the list having 3 elements only. This is my start. This is 100. This is 200. This is 300. So this address part is start equal to 100. This address part equal to 200. This address part equal to 300. This is null. So this is the diagram of the single linked list. Okay. Now p equal to start. So p is a pointer that is pointing to the first node. P equal to start. P not equal to null. In this case, the value of p equal to 100. As 100 is not equal to null, this condition will satisfy, and this printf will be executed. Printf %d p of info. Let p of info equal to 20, 30, 40. 20, 30, 4. Okay. So what is the p of info? 20 is now going to display. I get the information 20. Next, what is the updation? P equal to p of next. P of next में क्या है? 200. Okay. P of next equal to 200. So now this p value is updated to 200. P value is that pointer is now pointing to 200. This pointer is now pointing to 200. Okay. Now it is not 100. It is assigned to the value 200. So the value of p equal to 200. Now this condition you have to check. P is not equal to null. 200 is not equal to null as the condition is true, and it is going to print the p of info. What is p of info? 30. P of info is 30. So 30 is going to display. Okay. So now next p equal to p of next. What is p of next? What is p of next? At the 200 address, what is the p of next? What is p next? अगर मेरा pointer 200 is pointing to 200, in the 200 location, what is the next part? 300.
Start.
What is the next part? 300. Okay. Next part is 300. Info is 30. Next part is 300. Okay. That means it is the link part or address part. 300. So the value of p equal to 300. Is 300 equal to null or not equal to null? 300 is not equal to null. Okay. So this condition is true. Now this printf is going to print at the 300 location at the, so that means now this link is established. P is now pointing to here. P is now pointing to here. Okay. So at the 300 location, what is the information part? The information part is 4. The information part is 4. Okay. Now what is the updation? P equal to p next. So what is the address of the next? What is the address in the next field at 300 location?
Null.
Null. Now p equal to null. Now p equal to null. Okay. So now the value of p equal to null. As p equal to null, this statement will not be executed. This statement will not be executed. So what is the output I am getting here? 20, 30 and 4, which is nothing but the information part of 3 nodes of the linked list. 20, 30 and 4. Okay. All of you clear in the display of the single linked list?
Yes.
Okay. Now just main function. So this is the menu driven program. While one. While one means, you can say while one. You can say what is while one? While one means while true. That means if
While
the
true.
condition until while true. That means this loop is executed forever. This loop is executed for the infinity times. Okay. While one means it is executed for number of times. It is true always. You can write 2, 3, 4, 5, 6, anything, any value. Okay. While one. So this condition is always true. First, I have to write the create list, display. So these are the different menus. Only I am going to create and display. 3 to quit. Enter your choice. Okay. So first let's run this program, then you will get the idea. So first one is enter your choice. If I try to, before creating the list, if I display the list, then what I get? What I get? I get the empty list. Okay, till now the list is not created. I'm choosing the option 2 to display the list. So I get the output empty list, try again. Okay, after that this output is coming due to that while one. Okay, and until you are not pressing the quit option, that option is true again and again, and you have to enter the choice. Next time, suppose I enter the choice 1 for the create list. How many nodes you want to create? Let I create 3 nodes. Okay, enter the information part. First part is 12, 23, 34. So I give 3 nodes, 12, 23 and 34. Okay, now I have to, this you can see how many nodes you want to create. I press 3. Information part I have given 12, 23 and 34. If I press display the list, for displaying I have to press option 2. So it is going to display single linked list elements are 34, 23 and 12. Okay, 3 to quit. If I press 3, I quit from the execution of the program. Okay, because in the case 3 I am writing the function exit 0. So this way I am going to make up that condition as false, and I am coming out of the for loop. Okay, all of you clear? Any doubt at any point you can ask now.